I'll be reading from the September-October 1988 issue of Microcornucopia. This issue is very database-centered, which explains the enormous filing cabinet artwork we're looking at. The title of this article is ANSI, the Grand New C, written by Scott Robert Ladd. Scott concentrates this issue on the numerous additions the ANSI committee has made to the C language. Plus, he updates us on the new versions he's received and the new versions he's heard rumors about. Excellent journalism here. This column is going to be another grab bag, just like the last one. While there have been no new compiler releases, other products of interest have been piling up on the sofa in my office. So let's dig in. K&R 2nd Edition. Wandering through a bookstore a few weeks back, I ran across the new edition of Kernighan and Ritchie's classic book, The C Programming Language. This is an updated version of the work known among C veterans as K&R. I commend Kernighan and Ritchie for avoiding the tendency these days toward 1,000-page tomes. The 2nd edition is only slightly larger at 270 pages, than its predecessor. So what's new? Primarily, the 2nd edition follows the draft standard being developed by ANSI, which is the American National Standards Institute. The original examples have been refined and new examples have been added. The discussion of pointers has been rewritten and expanded. Some ambiguities in the text of the original have been clarified. There are also some new utility programs which, for example, convert complex declarations to human-readable text. These are an excellent aid in learning a somewhat confusing subject. For those of you still using Unix or K&R 1st edition standard compilers, Prentice Hall has promised to continue publishing the 1st edition of K&R until compilers based on the ANSI standard are universally available. I highly recommend this book to anyone who seriously programs in C. Okay, so what is ANSI C? A good question. While the standard isn't complete, most of the primary details have been hammered out. While some compilers adhere to the standard, many do not. Some vendors are waiting for the standard to be finalized, an event which probably won't occur until late this year. Let's take a look at some of the things which have been changed or added with the ANSI standard. I'll try to explain why these changes were made and how to use them. The ANSI committee's goal is to officially standardize the C language. Based on current programming practice, the standard will promote the portability of source code from one compiler and environment to another. Also, the committee is attempting to solve some of the problems with K&R C, such as the lack of type checking and function calls. C is well known for having very few reserved words, also known as keywords, only 27 in the original K&R version, as opposed to over 200 in a modern dialect of BASIC. ANSI has added 5 more for a total of 32. The new keywords support new or enhanced data types. 2 new keywords are const and volatile, both of which are qualifiers. When a data item is declared as const, the compiler will not allow its value to be changed. This can make the final object code more efficient, for instance. And then they give an example using a variable pi with a constant value of 3.1515 and so on. In a traditional program, pi would be put into a #define directive, and a separate constant would be created in the program's data area for each reference to pi. Some compilers are smart enough to make only one constant for identical references, but this is not true in most cases. So that's interesting. In their example, I read what they wrote, and that is pi equals 3.1515. That must just be a typo. One that they do not make again in the paragraph that I just read to you. Well, anyways, they go on to say, using const, only one copy of pi is generated, and that single copy will be accessed by both references to pi, and the compiler won't allow any statement which changes pi's value. Declaring a variable to be volatile indicates that it can change at any moment asynchronously. For example, a global variable which is accessed by an interrupt service routine would be declared volatile to prevent the compiler from making any assumption about its value. And the next keyword they go over is void. They say that a new type has been implemented called void. Something declared to be of type void indicates that it has no values. For instance, some criminals are of type void. That's why I love reading these old magazines, the jokes. They're just so wonderful. They go on to say an example of this would be a function which does not return any data. Okay, a function that doesn't return any data. You can declare a pointer to void. It isn't a pointer to nothing, but rather a pointer to anything. Any type of pointer can be assigned to a void pointer and vice versa without a cast. Functions such as malloc return a void pointer under ANSI. And since I couldn't find a copy of this magazine online, and I say down here that I'll be putting the text on GitHub, if you see any errors in the text that's appearing before you that I have not fixed, feel free to submit a pull request. Okay, moving on to the enum keyword. ANSI added this as an abbreviation to enumerated. So we have an enumerated type. Enumerated data. An enumerated data type is used to define a special set of related integer values. For example, the names listed in rankings are actually integer constants with first set equal to 0, second to 1, third to 2, and fourth to 3. A variable of a specific enumerated type may only be assigned an integer constant already defined for it. So for instance, if we have a current rank equals first, actually current rank is an integer data item set to 0, which is the value associated with first. You can also specify values for enumeration constants. Okay, and so there's the example they give using coins. If you declare a type to be of type coins, then that variable can only take the values listed. Not only can enumerated types make your program more readable, but they can also prevent you from assigning invalid values to variables. Next we have prototype. In my opinion, the most valuable ANSI enhancement to see is the function prototype. A prototype is a function declaration which includes information on its return and parameter types. Prototypes for library functions are in standard header files, while prototypes for functions in the current module are placed near the beginning of the program. This is an example of a prototype. When the compiler sees a call to a function declared with function prototype, parameters passed to the function will be checked to be certain they are of the correct type. KNRC did no parameter type checking, allowing, for example, an int value to be passed as a pointer or vice versa. This can lead to a very subtle error, could lead to subtle errors which are hard to track down. The above program line makes sure that any calls to fputs have two parameters, an integer and a stream file pointer. Type checking is also done on the return value to make sure it is assigned to a pointer to character. Note that type checking can be circumvented by using explicit casts. The void data type can be very useful in function prototyping, as in these examples. In the first example, malloc is declared as a function with a single unsigned type, which returns a generic void pointer. Init is declared to have no parameters and no return value. Function definitions also have undergone some changes. A classically defined main function might look like this. So doesn't it look amazing to look at code in Microsoft Word? I know that looks awful, but they're trying to point out that that's the old way, where under ANSI it could be defined like this. So that looks a lot better, right? The author says, I'm not sure which is clearer. The second version of main looks a lot like a Pascal function definition. The choice of how to define a function is up to the programmer. These are just a few of the new features the ANSI committee has added. Other new items include structure, passing, and the standardization of header file names and contents. With all these new features, though, nearly every program written under the K&R standard will compile without problem under the ANSI standard. The next section is titled Power C Bug. Mix Power C still has a few bugs. Version 1.1.1, which is the latest as of this writing, has probably the dumbest bug I've yet encountered in a compiler. Any statement which combines integer constants and floating point numbers will crash the optimizer pass. Adding decimal points to the constants solves the problem. However, a C compiler is supposed to do an automatic cast of an integer constant to a float in these cases. While I still think Power C is a good buy, for the manual alone, this type of bug indicates they're not paying attention to details. The next section is about Microsoft C. So it looks like that's version 5.1 and Quick C. So while Power C comes on a pair of diskettes, Microsoft C 5.1 arrives on, catch this, 14? 2 of which are 1.2 megabytes high-density disks. And yeah, I did not read that incorrectly. Remember, this is 1988. This is because of the support for OS/2, which necessitates duplicate versions of some of the programs. The compiler generates both MS-DOS real mode and OS/2 protected mode executables. In the last column, I mentioned that the NIC V20 microprocessor can execute instructions for the Intel 8186. Many compilers, including Turbo C and Microsoft C, can generate this kind of code, which is slightly faster than for the 8086, and Word Dictate just butchers syntax like that. But they're saying these compilers can generate code for any of these 4 microprocessors. In the next paragraph, he writes, unfortunately, Microsoft's compiler assumes that you have an 80287 math coprocessor if you compile for the 80186. The V20 is always installed in an 8088-based machine and will have an 8087 rather than the 80287. This problem only occurs when using the default floating point option. Which generates inline instructions, which are used by either a coprocessor or the emulator. So if you have a program which contains floating point calculations, you need to compile using that option, which tells the compiler to generate calls to the math library as opposed to inline instructions. There's another, though minor, bug in the printf and cprintf functions. When displaying a floating point number declared with a precision of 0, these functions show leading spaces rather than leading zeros. Microsoft has released a patch for this bug, and I have uploaded it to the Micro Cornucopia RBBS as... Okay, so he gave us the location there. Next section is called benchmarks. Several readers have commented about the benchmarks I use to compare MS-DOS C compilers. While most of the comments have been favorable, others have not. One reader suggested that the benchmarks could be made much better by tailoring them to each individual compiler's capabilities. He showed that by tweaking the benchmarks lets C's performance improve. This is a valid point. Any program, benchmark or not, will run faster when it takes advantage of the strengths of the compiler, and the hardware. Unfortunately, there are 2 problems with this. First, there's more to software development than program runtime. Second, most programmers don't know enough about their compilers to take advantage of faster methods. What is fast for one compiler may be slow for another. I have found in the past that no matter how much it looks like one hardware type and compiler will be used for a project, there is always a possibility of porting the code. Portable programs are written to be independent of operating system, hardware, and compiler dependencies. Editor's note also that next version of the same compiler may require a completely new set of tricks for maximizing code speed. Okay, I'm going to jump to the rumors section. He writes, it's not a very well-kept secret that Borland International is working on symbolic debuggers for their Turbo C and Turbo Pascal compilers. What is a secret is when they'll be releasing them and what they'll look like. They won't tell me, obviously hiding from the media. Please feel free to drop me a letter, call, or post a message on the Microcornucopia RBBS. And Scott Ladd here, he signs off by saying, may you program in interesting times, ...